Hello everyone. Today we are going to start a new data structure that is linked list. So before I go to linked list, let me before concentrate a little bit about array. So array is a contiguous data structure. So all the elements are stored in contiguous manner in our memory. Let's say this is my memory and this is my array. So all the elements are stored in contiguous manner, and if my length of my array list increases, it will cross. And suppose I have lesser memory, it will cross the limit of memory, and I cannot store more than this limited memory area. So although I have memory space available down below, but array is contiguous and it cannot store down below the memory. So I cannot store more than this. So in that case, here comes the linked list. So let's see what we can do is with the linked list. So this is my memory, and in linked list it stores two things, same as list data and address to the next node. Let's say that is 4x. So that is not necessary that 4x is just just next to it. It can be anywhere in the memory, and it holds the data and address to its next node. Similarly, this doesn't this will hold data and address to its next node. That is not necessary that it will be contiguous. It can store here as well, anywhere, wherever it want, it can store. So the difference is it doesn't store in a contiguous manner, and it stores the address to its next node. Now here, if 3 its next node is null, that means it doesn't have any node that's next to it. So our linked list terminates here. So for linked list, for starting we need a head. We can start with our head, and termination point is wherever we will get null. So that's our linked list. It We can use it if we want to use like if we don't want to use a contiguous manner, and we have a limitation on memory, then in that case we can use. Let's suppose this part of memory is not available for me, but this part is available. So in case of array list, I cannot store beyond this point and not below this point as well, because it will store the in a contiguous manner. But in case of linked list, I can store below that. That's also possibility, and this point also. All we need is address to the next node. That's it. So that's the linked list. So if we see, we want to get an element in an array, so we can call the get in an array list, we can call the get index, and it will give us the element. But if you want to get an element in a array list, in a linked list, then what we have to do is we have to traverse till here, and then, because in linked list our only point of reference is head. Through head only we can search for anything. So we can go, and if we want to find 3, we get 3 here, but for that we need to traverse through 1 to 3. Why? Because we don't have any direct contact with these 3, but in array list they are stored in a contiguous manner. So if we know the address of this one, we can say just after, if it address is 4x, then we can predict the its address, it's definitely would be 6x, because it would be contiguous. So in that case, our like getting any element is very easy, like is O1 complexity, but in English it's of O(n) time complexity. So if you want to search an element, like if you want to get an element in array, it's constant time complexity of O1, and in English it's O(n). So if our application is read specific, then we should use array. But here comes the uses of linked list. In an array, what happens when we want to insert an element? So I want to insert 4 here, just after 3. So what happens in an array? 1, 2, 3, and it will what it does is it shifts all the elements to one step. So it will, earlier there was 5, there was 6. Now 4 wants to come here, then 5 will be shifted, 6 will be shifted, and after shifting, let's say 5 is shifted, 6 is shifted, and then comes our 4. So that shifting happens. Let's say this array is too big. So shifting operation is taking some time. But in case of linked list, what happens is, let's say we have a linked list 2, 3, 5, and 6. Okay. So here after 3, we want to insert 4. So if somehow we can get to this 3, what we can do is, after 1, this 2, this 3, we can add 4, because it is pointing. 3 is pointing to 5. So what we can do, we can have a reference to 5, and we can point 3 to 4, and then 4 to 5, and 5 is already pointing to 6, so there is no issue. So in case if you want to insert anything in mid, in that case, our linked list is more efficient than our array list. So in that case, we will use linked list. So that's the most common use case where array list fails. So first is memory. If you want have memory restriction like contiguous, and then in that case we can use linked list. And other is if you want to insert specific one, if you want to insert like many times in the middle, then we should use linked list. And if we see the linked list, it stores two things: data as well as address of the next node. But our array list stores only the data. So in our linked list, we can say it is taking double the memory, double the memory than our array list. It's because it is also storing data as well as the address to the next node. So I hope you got the point. Now let's see the real world use cases of linked list. So linked list also have some types: singly linked list, doubly linked list, and circular linked list. So we will talk about more in detail, but for now let's know the names. So in singly linked list, we can traverse only forward. In doubly linked list, we can traverse forward and backward as well. And what happens in circular linked list, it creates a uh, like it never ends. It creates a loop type of structure. So we will go each of them, but let's see the use cases. Let's say we have a playlist. I'm telling about real life use cases. So in playlist, what happens is we have song 1 and song 2 and song 3. So we will start from head. So head is song 1. We start with song 1. We went to song 2. We went to song 3. and there is another song. So we went to song 3. Then I want to hear again song 2. I am hearing song 3. After hearing song 3, I found out that I should once again hear song 2. So we can come back here and we can listen song 2. Song. So in what happening is we are using W linked list. We can, if we I want to go next, I am using next pointer. If I want to go backward, I can use forward pointer. So this is a one use case. Other is our browser. In our browser, we we browse first site, then we browse second site, we browse third site. Then after third site, I went back, and after going back, I see, oh, that is, I went forward. So what's happening is all the sites, all the activity I'm doing is getting stored in a node. And whenever I'm going forward, it is letting me go. It is adding a node and pointing to that node. When I'm going back, it is referring to the previous node. So like this in a browser. In code editor also. So whatever changes we do are stored in a new node. Let's say I have written a word ABC. These are stored in node 1. Then I have written a word D. So that is stored in another node. Then next time what will happen is something like this. I did control Z. I did control Z means this node I want to go back to this node. So this my pointer is pointing to this ABC now, and it will not show me this. But after some time I thought, oh, that was the correct. Then I did control Y. Then this pointer would come to this point and it will bring back this whatever I have done in this node. So these are some real life use cases of linked list. So in next video we will create a linked list and see what happens in a linked list, and after that we will solve its problem. Thank you. Have a great day.